Founded by the European Union, the INNOVA project is a Marie Sklodowska-Curie Action Doctoral Network within the Horizon Europe program. The main goal of the INNOVA project is to develop the noise reduction method by training DCs through intersectoral, multidisciplinary, and international joint research in engineering, acoustics, and material science for both academia and industry. Firstly, let's dive right and learn more about the INNOVA project. The INNOVA project is an international consortium of high-profile universities, research institutes, and companies located in Poland, Spain, Belgium, Italy, Germany, and United Kingdom. Our programs offers well-structured PhD trainings with innovative elements. Doctoral candidates will conduct experimental research in most advanced vibroacoustics laboratories. They will also benefit from strong universities academia collaborations through business-focused events, intersectoral project secondments, and joint supervision by both academia and industry experts. Scientific objectives of the INNOVA project are related to the transmission of noise into and from encapsulated structures. It can be divided into two key objectives. The first one, develop a comprehensive noise reduction casing solutions that effectively controls the excessive noise produced and emitted by industrial devices and household appliances. This solution uses significantly less energy, sensors, and actuators than traditional active noise control systems. This is the in-out problem. The second one is to develop a versatile active and passive control techniques for the reduction of noise transmission into encapsulated structure represented as vehicles and aircraft cabins. This is the out-in problems. The INNOVA Doctoral Network, for the first time, will investigate the reduction of noise passing through encapsulated structure, considering both in-out and out-in forms of this problem. Exploration and integration of synergy between the hitherto disjoint noise control techniques will create new knowledge and enable development of new complete system, reducing noise generated by devices and in cabins. Each project gives candidate hands-on experience in noise solutions development. They work on analysis, design, application, and industrial testing. This happens alongside their academic studies. Training takes place in leading sound and vibration labs. It also involves European companies. Next, we will hear the DC's presentation. They will explore past and current noise technologies. They will also compare them to the benefits and advanced noise barrier technology.
Hello everyone, my name is Amir Hafiz. I am doctoral candidate 1 from the INNOVA project. My work is focused on distributed control algorithm for active device casings. Conventional multi-channel ANC systems use the FXLMS, centralized FXLMS algorithm. This is beneficial for small-scale systems, but for large-scale systems, distributed control system is beneficial since it distributes the computation burden across multiple processors. And this is what we are trying to implement in this laboratory using these multiple boards. Thank you very much for listening.
Hello everyone, my name is Khalid Ma'moon and I am a PhD student in Silesian University of Technology within INNOVA project. My topic is addressing active noise controlling casing that has an opening. The opening is important in vibroacoustic systems because it can give the ability to have more airflow, so more cooling for the devices, and also it can give the privilege of monitoring the device or doing some maintenance. Within the past few months, we have reached good results about the shape and the location of these openings and their impact into reducing the sound power response of the system. You can check these results on our publication that can be found on the project websites or social media platforms. And currently in our lab, we are trying to test the active noise control by setting some structure actuators on the plates, hoping to have more enhance sound power characteristic for the system. Thank you.
Hello everyone, my name is Alkafa Buchimon, and I'm a PhD student in the Innova project, the DC3. My PhD topic is about the deep learning-based active noise control through encapsulated structure. The environment of control is encapsulated structure, which means cars, trains, or aircraft. Here we are in the lab where there is my experimental setup, the noise box. This is a structure designed to simulate car interiors, and the aim of my PhD will be to develop a deep learning algorithm which will control the noise from outside the noise box to inside the noise box. Here, deep learning can be a very powerful tool to overcome limitations imposed by traditional algorithms, such as the management of nonlinearities linked to the environment and capture the spatial patterns of the acoustic wave. So on this setup, I can compute the primary path and the secondary path and implement them in control algorithm. That's all for me. Thank you.
I am Chao Liang, DC4 of the Innova project. My topic is to develop ANC algorithms using direct data-driven control, namely DDDC. The difference between DDDC and traditional algorithms is that it doesn't rely on system identification. For example, it doesn't need the estimation of primary or secondary paths. Besides, it only needs the past data of input and output to directly update the controller. So it's actually more adaptive to various environments. After the algorithms, we have the validation stage. For example, we have the Queen tube used for the realistic sound environment, and we have the speed code for the implementation of our algorithms. So we can use the speed code to control the noise inside the Queen tube to validate our algorithms in real time. That's all. Thank you.
Hi, I'm Tahmida, a doctoral candidate from UPV. So in Innova project, each doctoral candidate have their own objective. For my project, we mostly focused on the control algorithm of ANC, active noise cancellation systems. From the inception of ANC, most control algorithms are based on the least mean square method. And it's commonly used in ANC headphone, road noise cancellation, in other real-time application, and they are effective. But with the improvement of DSP processor, it will be nice to focus on more effective and improved algorithm. So in UPV, our group is trying to develop and implement algorithm that will have better performance than available least mean square based algorithms. Thank you.
Hello, I'm Andrei Hensi, a PhD researcher at Siemens working in the Innova project. I'll give you a fast overview of my research topic, where the final goal is to provide innovative tools for engineers to develop quieter vehicles. Noise inside a vehicle cabin is not a simple thing. It is quite complex, challenged, and it's influenced by many design factors. It is crucial for car manufacturers to identify and reduce the noise sources and paths efficiently as early as possible in the vehicle development cycle. My research aims to tackle these problems by merging knowledge-based and data-driven engineering, or in other words, merge machine learning capabilities into the engineering development workflow. With recent machine learning breakthroughs, we can map more complex relationships between design and final performance. By merging the traditional numerical simulations with AI, we can enhance the efficiency of our analysis by predicting faster and extracting the most relevant information out of it. Our goal is to create accurate models to help in the early phase design exploration. This involves evaluating the vibroacoustic performance of electrical vehicles by using a rebit modeling approach where the data can come from test and from simulation. We also want to explore topics such as AI explainability to increase confidence on the outcomes and to increase the understanding of the predicted relations. I'm excited with the next steps of my research and the applications we'll have in the future.
Hi, my name is Maria, I'm DC8, I'm from UPB, and my project is a perceptual broadband ANC equalizer with spatially distributed user-selected profiles. So within my project, I've been working mostly with audio samples and signals, noise signals that we can find inside of the vehicle cabin. And something that has evolved and changed dramatically over the years is of course the processing power of DSPs. We have gone from working with very basic DSPs up to the point that we can work with hardware that can run and simulate in real time. That enables low latencies to the point of reaching the nanoseconds, the milliseconds, and that's all we really need to get a great performance. So here at the lab, we work with SpeedGoat. We have also worked with the ADSP SC584 from Analog Devices, and those two are like highly sophisticated platforms that help us to go through the point that we really want. And I think that's a technological advantage that is great to highlight. And that's all for me. Thank you.
Hello everyone. My name is Saidel Kazmiri Pedroza, and I am the doctoral candidate number 9 in the Innova MSCA project. I do my PhD at the German Aerospace Center, and I am working in a really exciting topic: contribution analysis of different aircraft interior parts to overall cabin noise. I know that this is a really long name, but in simple terms, I study how vibrations from different parts of the airplane contribute to the noise that passengers hear inside the cabin. To do this, I use the finite element method, a well-known computer simulation technique, along with something called transfer path analysis that helps identify the paths that noise and vibration take through the airplane. What's new about my research? Here are the 3 main points. First, saving computational resources. I'm working on making the simulations faster and with less memory requirements. 2, a new way to study transfer path analysis. So instead of using the usual frequency-based methods, I use dynamic substructuring and component mode synthesis. And 3, I apply these methods to a model of an aircraft to figure out how noise and vibration travel and what are the most relevant paths that passengers hear. By improving these methods, my research helps make aircraft noise and vibration studies more efficient. This could lead to quieter and more comfortable airplanes to everyone in the future. Thank you very much for listening.
Hello everyone. My name is Chong Guan, and I'm one of the doctoral candidates in the Innova project. My research involves around finding out more about the limitation of head tracking in a local active control system. In particular, we are looking more about the active headrest, and the design of the active headrest is made such a way that we do not need to wear any wearables such as the AirPods or any headphones, but still manage to create cancellation in our ears using a loudspeaker placed remotely behind. For example, you can see the figure over here. However, you may expect that for this kind of design, there will be a degradation in performance as the head moves, which is why Superior's work has decided to add a head tracker, so when the head moves, the head tracker can obtain the head coordinates and thus updates the controller so that it can emit the anti-noise at the correct location. However, in order to implement this method, there will be a lot of different additional factors to consider. One of the factors to consider is a tracking resolution, because in order to make this head tracking system to be as seamless as possible, you may need a lot of measurements within the tracking grid range. Which is why we need to understand, is there any trade-off if we decided to make the tracking resolution coarser while still maintaining control stability and performance. This is my work comes in, as my work aims to investigate how exactly the trade-off between the tracking resolution impact the control performance system, and also any potential methods to improve the calibration system without increasing additional measurements. Thank you.
Hello, my name is Achilles. I'm a PhD candidate in the Innova project. My project is on virtual sensing methods in the context of active noise control. There are times that you cannot place measurement equipment at the positions you would like to control a sound field. So this is when virtual sensing methods kick in to allow for the estimation of sound fields at remote locations. However, their performance suffers when inside complex sound fields, such as those encountered in aircraft cabins or cars. So my contribution in the Innova project is to improve the performance and robustness of such methods to allow for better control over larger areas. The approach we have adopted is to use the pressure gradient of the sound field to introduce additional information in the estimation process through multi-microphone configuration.
Hello, my name is Zulfur Rahman, doctoral candidate number 13 from University College London. As part of the Innova project, my research focuses on applying soundscape principles to improve indoor acoustic environments, especially in open plan offices. So for those who are not familiar with the soundscape, so it is a method to study and understand how people perceive the sounds in their environment. So instead of relying on acoustic metrics, this method focuses on a human perspective, how they understand about the sound, how they feel about the sound, or how the sound may affect them. So it is really relevant to open plan offices, which are designed to foster collaboration and efficiency, yet often face challenges such as noise disturbances, which impact the overall well-being and also productivity due to the absence of partitions or walls within the spaces. So our research explores the combination between noise barriers and also soundscape approach to address these challenges. So to support this work, I utilize advanced technologies such as acoustic simulations and also VR technologies to create realistic scenarios to test for testing and also refining the effective solutions. And moreover, as part of the Innova project, I have been equipped with so many workshops related to noise barriers, and also I have had the opportunities to work and also collaborate with leading institutions to achieve the primary goal of my research.
Thank you for watching this movie. We hope you have learned more about the research in the Innova network. PhD students in part of this project are working on different ideas, like reducing noise using smart materials, or applying artificial intelligence to sound and vibration. We hope that this work will help to create quieter and more sustainable solutions in the future. Thanks again for watching, and see you next time.